The topic is contour diagrams. So let's do this example. Sketch at least 4 labeled contours for f of xy equal x squared minus y squared. So let's read the definition. A contour at z equals c is the set of points xy such that f of xy equals c. So what does that mean? A contour for this function, of course, f of xy equals x squared minus y squared, at the height z equals c is the set of all points xy such that x squared, f of x, y means x squared minus y squared, is equal to the constant c. So how do we graph that? So let's try to let's look at the contour for c equal 0. C equals 0 means x squared minus y squared is equal to 0, right? Which means there's two ways of doing this. You can just do it this way. Y squared is equal x squared. If you square root both of them, y squared equal x squared means square root of y squared is equal to square root of x squared, which means absolute value of y is equal to absolute value of x. This tells us that y is equal to x or y is equal to negative x. Or you could factor it. Let me show you the other ways. In other words, you're going to get two lines, y equal x, y equal negative x. You could also do x squared minus y squared is x minus y factor of x plus y. That's supposed to be equal to 0. That means this is 0 and this is 0, which means y equal x or y equal negative x. So you get the same thing. So let's graph. So that's at c equals 0 we get two pairs of lines. Y equal x when x is equal 0, y equal 0 when x equal 1, y equal 1. So here's this is y equal x, so c equals 0, and then we get another line when x equal 1, y equal negative 1. We're graphing y equal negative x. So that also corresponds to c equals 0. Alright, make this a little bit. Alright, what else? Let's use c equal 1. If c is equal to 1, for c equal to 1 we get x squared minus y squared is equal to 1. Now, this is the same thing as x squared over 1 squared minus y squared over 1 squared. And if you look at this definition, that we're going to get a hyperbola. So hyperbola with a, remember a is equal to 1, right? So the x-intercept will be, in other words, the vertexes will be at x equal negative as x-intercept, right? So that would be, let me do it here. So this will be the graph. So this will be c equal 1. C equal 1. Right? Now what about c equal 2? C equal 2 means x squared minus y squared is equal to 2. Now what we do, we divide by 2. So x squared over 2 minus y squared over 2 is equal to 1. Now the equation looks just like that one also. You can rewrite this as square root of 2 squared, square root of 2 squared. Now my a happens to be square root of 2. So I need a minus square root of 2, which is minus 1.4 right here. So it will be c equal 2. And then I need square root of 2, which is 1.4. So we have another hyperbola right there. So this will be c equal 2. Now let's use some negative numbers. What if you have c equal -1, and this means x squared minus y squared is equal -1. Now here what we do, divide everything by -1, then what do you get? Y squared, or multiply left side by -1 and the right side by -1. You get this, right? So which means it's still a hyperbola, but with the vertices will be on the y-axis. So again, I can rewrite this as 1 squared, so my a still happens to be 1. So I'll go to 1 and I'll do the hyperbola, and then I go to -a, which is -1, and I do this part. Right? Now let's do c equal -2. Same thing, x squared minus y squared is equal to -2. Divide everything by -2, or divide by -1, then divide by 2. So you'll get y squared. Let's do it in 2 steps. Multiply everything by -1. Y squared minus x squared is equal to, then divide by 2. You get 1, which is just square root of 2 squares, square root of 2 squares. So my a happens to be square root of 2. It's in the y-axis. Still, I'm looking at this equation. Square root of 2 will be right here, 1.41. Oh, by the way, I forgot to do, that would be what? C equal, this will be c equal -1. And this will be c equal -2. C equal -1, and I need square root of 2, which is 1.41. And this will be c equal -2. So we get hyperbolas. And that's it for this example.